Hello, and in this lesson we'll be looking at calculating the mean, median, mode, and range in particular data sets. So in this question we've been given a set of data that's been presented in a frequency table and a stem and leaf plot, and we're required to calculate the mean, median, mode, and range for this particular set of data. First we're going to look at mean, and mean is what is also known as average, and the mean is equal to the sum of scores divided by the number of scores. Or in the case of a frequency table, the sum of scores, fx, divided by the sum of frequency, or f. They're the same thing. So what we can do to calculate that is add up all of our fx column, which is 243, and divide that by the number of scores, which is divided by 9. So in this case our mean will be equal to 243 divided by 9, which is equal to 27, meaning that the mean score has a value of 27. In the stem and leaf plot, we would do it the same way. We would just add up all of our individual numbers and then divide it by 9, or the amount of numbers in the data set. For median, median is the central value in our set of data. It is the very middle value. If we were to write all of our numbers out in order, it would be the number or value that sits in the middle. For example, I could write out a set of data from 1 to 5. The median in this case would be 3 because it sits directly in the middle. When we are calculating median for a stem and leaf plot, it's quite easy because our data is already set out in a very similar way. So we can essentially cross out from either side until we end up with a middle value, which in this case will be 29. So I'll put 29 there. When we're using a frequency table, finding the median can be a little bit more difficult, and this is the time where a cumulative frequency column can be quite useful. So I'm going to quickly fill that in. That's going to be 1 plus 2 is 3, plus 1 is 4, plus 3 is 7, plus 1 is 8, plus 1 is 9. Now, what we can do is figure out the middle number. Now, the middle number is figuring out the position of the number that is in the middle of the set of data. And we can calculate that by finding out n plus 1 over 2, where n is the total number of values in the set of data. In this case, n is equal to 9. Therefore, our middleth number is equal to 9 plus 1 over 2, which is 10 divided by 2, which is 5, meaning that the fifth number will be our median number. And we can look at the cumulative frequency table, or column in our frequency table, to determine what the fifth number will be. We know that the first number is 20, that the second and third number is 23, the fourth number is 25, and the fifth number is 29. So in this case, again, the median would be equal to 29, as the fifth number in the set of data is 29. For the range, for the mode, Our mode is the most common or most occurring number in the set. And so that will be again the same for both sets of data. In our stem and leaf plot, we look for the piece of data which occurs the most, which is clearly 29. And in our table, we look for, again, the number which occurs the most, and we can see that in the frequency part of our table. 29 has the highest frequency, which means that, again, the mode is 29. D, our range, gets us to find essentially the gap between our highest and lowest values. And our range is expressed as our highest value minus our lowest value. So in this case, we would look for our highest and lowest value. It's quite obvious in our frequency table as well as our stem and leaf plot because they're the first and last entries. And we would calculate that as 34 being our highest minus 20, which is our lowest, and that is equal to 14.